This is the solution to USACO Bronze, December 2022, problem number 1, Cow College. So the setup of the problem is that there are n cows, where n is less than or equal to 10 to the fifth, who can attend a university. Each of them is willing to pay a max tuition of CI less than 10 to the sixth. And Farmer John can set the tuition that all cows must pay. And a cow will attend this college if, as long as the tuition is less than the cow's maximum tuition of CI. So Farmer John wants to see how much money he can gain from this setup, which means over all possible tuitions he could charge, which will generate the maximum amount of revenue from the cows that buy into the college. And so our sample is we have an input. We start with n, and then we're given n integers. So here n is 4, and then we're given 4 integers, 1, 6, 4, and 6. Each of those is one of the CIs. And then we want to output the max amount of money that Farmer John can make and the optimal tuition he should charge. In this case, the optimal tuition is 4. So we can see that if he charges 4, then 3 cows will buy the ones that have CI equal to 6, 4, and 6. So he will make 4 times 3 equals $12 total. And then we see that this is actually the maximum because, well, there's other choices. For example, you could set the tuition to 6. In that case, only these 2 cows would pay, and you'd make $12 in total. Or you could set the tuition to 1, for example, and only 4 cows would pay, and you would make $4 in total. So actually, either of these two will work. Either charging a tuition of 4 or a tuition of 6. Both of those will give us the optimal tuition. However, the problem statement says that if there are multiple solutions, output the solution with the smallest optimal tuition. So that would be 4. And so our output is 12, which is the max amount of money, followed by 4, which is the tuition that Farmer John should charge. So I guess, like, how do we think about starting this problem? First of all, it doesn't appear clear that we can just brute force it. N is 10 to the fifth, which means that any solution should probably be like O of n or O of n log n, meaning that our solution should be like some sort of linear sweep, or something of that form, instead of just brute forcing every possible tuition that Farmer John could try, and then seeing how much money he gets from each of them. So yeah, so we need to be a little smarter about this. So one observation that you can make is that, firstly, the tuition that FJ charges should be one of these numbers in the input, one of the CIs. And why is that? Well, let's say that it's not one of the CIs, right? Then we could decrease the tuition and be able to get the same amount of money from everyone. So, for example, let's say we charged a tuition of I don't know, like 5. In this case, the only cows that will be able to afford it are these 2 cows here. But we can gain more money by just increasing this tuition to 6, without actually changing the set of cows that will buy into the college. So the idea here is that if the tuition is not already one of the CIs, then we increase it up to the next highest CI, and that would give us like a valid tuition with more, like, where we definitely make more money. So this is like the first observation that we should make. Okay, and the next thing we can claim is that I guess, like, to approach this problem, notice that, like, if a cow if you have like one cow that is willing to pay CI and another cow that is willing to pay CJ, where CI is less than or equal to CJ, that means that like cow J will buy any or will pay any tuition that cow I will. So the reason this is super useful is because we want to count the number of cows that will pay any given tuition. And um, this gives us the idea to sort the list of CIs, and then check basically what tuition we should, and then check if like a given cow will pay a tuition, then all cows after it will. So to illustrate this idea, let's take the sample input. So we start with 1646, and if we sort this list, then we would get 1466. And now we need to try the different. So here will be the steps of our algorithm. Here. Start by sorting, and then we check each of the CIs. Because we know that these are the possible tuitions. And the way we will do that is we start with, let's say we start with 1, for example. We know that every cow after this 1 can afford like $1 tuition, which means that the revenue that Farmer John would generate is, if this is index I, then there are n minus I cows here that Farmer John could get money from, which means that like the revenue using CI is going to equal n minus I times CI. So this is the number of cows. And if we go on to I equals 1 here, then we'll get 4 times the number of cows here, which is 3. And so Farmer John's revenue would be 4 times 3. And for 6, it would be these 2 cows and I equals 2. So it would be CI, which is 6 times 2 would be 12. So this is the idea of how we're going to implement this. And then the way, as we do this linear sweep, we basically want to keep track of the maximum tuition that we've seen so far. Or not max tuition, but max revenue seen so far. And if we come across something better, than our max revenue, then we should replace it. And so one good thing about this is it will take care of the condition that if you find multiple ways of getting the max revenue, that you should return the smallest one. Because if we've already found a way to get $12 out of 4, then once we check that we got $12 out of choosing CI equals 6, we will know that we can just take 4. And we won't replace 4 at all. Okay, so let's look at the implementation. It is actually fairly simple. So this code. So yeah, we start by including bits and using our standard namespace. Here maxn is 185, and we will create an array C of size max n. And then now we can actually start writing out our function. So we first read an n, and then on the next line we read in all our CIs, and then we need to sort C. And in C++, that's with the sort function. So sort C and then the end pointer, which is C plus n. And then we'll have an answer. So here, I'm making sure to use long, long, because if you use int, it might overflow and you'll get a wrong answer. And I'm also going to want to keep track of the price or the tuition that Farmer John is charging. So finally, we need to do our iteration. So we iterate through all the CIs, and basically we'll check that if n minus I, which is the number of cows, times the tuition, which is CI, is greater than our previous answer, then we want to update answer to n minus I times CI, and we want to update our price to CI. All right, and finally we print. So do that using this. And we're done. That's the entire solution.